For this video, I would like to introduce to you the concept of integration. So, what do we mean by integration? Integration is actually the reverse manner of differentiation. So, what do I mean when I say that integration is the reverse manner of differentiation? So, we suppose a function y is equals to 3x squared plus 2x plus 4. So, when we differentiate this, we will get dy over dx, this is 3 times 2 x raised to 2 minus 1 plus 2 times 1 x raised to 1 minus 1 plus the derivative of constant plus 0, because the derivative of a constant is 0. Then, to further simplify, this is dy over dx, this is 6x plus 2. As you can see, this is the solved value for differentiation. But when it comes to integration, this is actually the particular uh, value that we are solving, so that we will able to get the original function that undergone differentiation. So when we integrate this one, we should get the original function. So what does I actually mean? Suppose we had a function ax raised to n, and its derivative is a times n x raised to n minus 1 dx. When we integrate this one, we should always get this original value. So let's try. The integral of a dot n x raised to n minus 1 dx is equals to a multiplied by n x raised to n minus 1, and in integration we are actually instead of subtracting 1, because in differentiation we are subtracting 1, in this case in integrals we add 1, and instead of multiplying uh, the power to this constant, we are dividing it. So this is n minus 1 plus 1. So simplify, this is nothing but a that n x raised to negative 1 positive 1 is always equals to n. This is negative 1 plus 1 cancels out, and as you can see that n cancels also, therefore we have a x raised to n, which is our original function. So that's why we called that integration is the anti-derivative or the anti-differentiation, because we are undoing the differentiation. And the symbol for the operation of integration is this elongated s. Okay? So as our example, let's use the value that we get from the differentiated uh, problem. Find the integral of dy over dx is equals to 6x plus 2. So to solve this one, we multiply dx both sides, therefore we get dy is equals to 6x plus 2 dx, and we apply the integration on both sides. Therefore, the integral of dy is nothing but y. And if we integrate this particular term, we can do it term by term. So this is an integral of 6. So this is 6x dx plus 2 integrals is 2 dx, and y is equals to 6 integrals of x dx. We factored out the constant, on the uh, left side because our variable of integration was x. Therefore, this is y is equals to 6 multiplied by x raised to 1 plus 1 over 1 plus 1 plus 2. And this is actually equals to x raised to 0 plus 1 all over 0 plus 1. Because anything raised to 0 is always equals to 1. Therefore, the 1 right here is actually equals to x raised to 0. Therefore, we get y is equals to 6 over 2, which is 3x squared plus 2x. And if you actually observe, this is actually the original function that we differentiated. Therefore, this is not the actual answer. So how can I say that? We knew the fact that the derivative of 3x squared plus 2x plus 4 is actually equals to 6x plus 2. And if we try to replace this last term with a negative 4, we can also get the same answer, which is 6x plus 2. If we replace again this with another value, which is negative 3, we can also get the same answer when we differentiated that, which is 6x plus 2. So this particular term right here could have various values that equates to the same output that we have when we differentiated this particular function. So to represent the various values that it could possibly be, we need to always add a constant of integration, especially in solving indefinite integrals. Therefore, this is the correct answer for this particular problem. So for our first example, find the integral of 3x squared minus 5 dx. So for the solution to solve this, we integrate it term by term. We factor out the constant 3x squared dx minus 5 integrals of dx. This is 3x2 plus 1 all over 2 plus 1 minus 5 x raised to 0 plus 1 all over 0 plus 1 plus some constant of integration. Therefore, this is 3 over 3 x cubed minus 5x plus some constant c. Therefore, the final answer is x cubed minus 5x plus c. There you have it. So for our next example, example number 2, find the integrals of x plus 1, negative x plus 2 dx. So first, we simplify this term right here. So for the solution, this is an integral of x plus 1, 2 minus x dx. The integrals of FOIL method, front, 2x, outer, inner, and last. It's negative x squared plus x plus 2 dx. Integrate it term by term. This is negative 1 x squared dx plus integrals of x dx plus 2 integrals of dx. We will get negative 1 x raised to 2 plus 1 all over 2 plus 1 plus x raised to 1 plus 1 all over 1 plus 1 plus 2 multiplied by x raised to 0 plus 1, 0 plus 1 plus some constant c. Therefore, we will be having negative x cubed over 3 plus x squared over 2 plus 2x plus some constant of integration. That is the final answer for that particular problem. So for our third example, find the integrals of 3x 2 squared x dx. So for the solution, this is 3x minus 2, that is 3x minus 2 times x dx, which also equals to, for using FOIL method, this is 3 times 3 is 9x squared. Outer, that is negative 6x. Inner, negative 6x. Last, 4x dx is equals to the integrals of 9x cubed minus 12x squared plus 4x, because we distribute this x right inside. Therefore, to find the integrals, integrated term by term, dx minus 12 integrals of x squared dx plus 4 integrals of x dx is actually equals to 9 x raised to 3 plus 1, which is 4, divided by 4 minus 12, x raised to 2 plus 1 is 3, divided by 3 plus 4, x 1 plus 1 is 2, divided by 2 plus some constant of integration. Therefore, the final answer is 9 over 4 x raised to 4 minus 4x cubed plus 2x squared plus some constant c. That is the final answer for example number 3. So for example number 4, this is the integrals of 1 minus x raised to negative 1/3 dx. So for the solution, we integrate it term by term. This is the integrals of dx minus the integrals of x raised to 1/3 dx. So integrals of dx is always x minus the integrals of this. The integrals of x raised to negative 1/3 is 1/3 plus 1, which is 1 is also equals to 3 over 3. Therefore, this is 3 over 3 divided by negative 1/3 plus 3 over 3 plus some constant c. Therefore, the answer is x raised to, x minus, this is 3 minus 1 is 2/3 divided by 2/3 plus c. Therefore, the final answer is x minus 3 over 2 x raised to 2/3 plus some constant c. That is the final answer for example number 4. So for our last example, example number 5, find the integrals of the root of x minus 1 all over root of x dx. But root of x is also equals to x raised to 1 half, right? And 1 all over root of x is also equals to x raised to negative 1 half. Therefore, for the solution, we substitute those values. And the root of x raised to 1 half minus x raised to negative 1 half dx, we integrate it term by term. This is x raised to negative 1 half dx minus the integrals of x raised to negative 1 half dx, and this is also equals to x raised to 1 half plus 1, that is 2 over 2, 1 half plus 2 over 2 plus x raised to negative 1 half plus 2 over 2, 1 half plus 2 over 2 plus some constant of integration. Therefore, the final answer is, this is 2/3, because this is 3 over 2, reciprocate 2/3, x raised to 3 over 2 plus this is x raised to 1 half, reciprocate 1 half, that is 2, plus some constant c. Oops, but this is actually subtraction. We replace subtraction. Therefore, that is the final answer for example number 5. So for this video, I hope you learned something from it, especially when it comes to the basic integration. So I hope you to see you on my upcoming videos. So that's all. Thank you for watching. God bless. Rufus boy, let me love boy, what you know. Rufus boy, let me love boy, what you know. Rufus boy, let me love.